Imagine a complex network of roads, with cars flowing in and out of intersections. No matter how many cars arrive, the same number must leave, right? This fundamental principle, that what goes in must come out, applies to the very heart of electrical circuits too. Yes, Kirchhoff's current law, often called KCL, can indeed be applied to any circuit node. This powerful law states that the algebraic sum of currents entering or leaving any junction point, or node, in an electrical circuit must be equal to zero. It is a cornerstone of circuit analysis, ensuring that electric charge is conserved throughout the network. The reason KCL holds true for every node is deeply rooted in the principle of conservation of electric charge. Electric charge cannot be created or destroyed at any point within a circuit. It can only move from one location to another. A node simply represents a point where two or more circuit elements connect, allowing current to split or combine. Since charge cannot accumulate or dissipate at a node, the total current flowing into that node must exactly equal the total current flowing out. This is true regardless of the type of circuit elements connected to the node, whether they are resistors, capacitors, inductors, or even more complex components like dependent sources, as long as these components themselves do not store or generate charge at the node point. To practically apply KCL, you first identify all the nodes within your circuit. Then, for each node, you designate a direction for every current entering or leaving it. Traditionally, currents entering the node are given a positive sign, and currents leaving are given a negative sign. You then sum these currents and set the total equal to zero, forming an equation that helps you solve for unknown currents or voltages within the circuit. This universality of KCL means that it provides a critical set of equations when analyzing any circuit, no matter its complexity. In nodal analysis, for example, applying KCL at every principal node allows you to determine all node voltages, which then allows you to find any current or voltage in the circuit. Understanding KCL as a direct consequence of charge conservation empowers you to confidently approach even the most intricate circuit problems. Therefore, KCL's applicability across all circuit nodes is not just a theoretical concept. It is an essential analytical tool that underpins your ability to accurately predict and understand circuit behavior. Mastering this fundamental law is key to developing a strong intuition for how current flows and distributes itself in any electrical network.